Welcome to today's video, where we'll delve into the inner workings of a surge protection device, SPD. In this demonstration, we'll show you the different components and explain how they work together to safeguard your electronic devices from power surges. First, a walkthrough. This is how an SPD looks when disassembled. First, there is a large blue component, namely a metal oxide varistor, MOV. This is the device that is responsible for arresting and safely earthing all the surges. The top of the MOV is connected in parallel with the load and the bottom is connected to ground. The line/neutral side of the SPD is connected through a thin and weak soldered mechanical joint. The mechanical shaft, the one you see in red, is held in place with force applied by the solder joint. There is a spring at the back and an electrical conductor. A black flap is placed to hide the red color from the display. And this is the body of the SPD, which houses the signaling connector and necessary components. When there is an undesirable surge, the device fails dead short, causing the large flow of current to ground to melt this solder joint. When the mechanical link has melted off, the spring on the back of the mechanical shaft pushes the shaft forward, indicating a failure on the front display. As you can see, the multimeter shows a closed circuit for a normal SPD and open for a failed SPD. After the joint is disengaged, the surge protector is no longer protecting the loads. A visual indication might not be enough, as it requires the user to intervene for a visual check. To solve that, there is an alternate method to indicate the failure, and that is remote signaling. When this shaft has been disengaged, the contacts inside the housing signal that the circuit has been opened. This is done with the help of tiny spring switches. This signal in turn could be hooked up to a contactor to shut down the system the SPD is trying to protect. Thank you.